Hello, everyone. Thank you for joining us. And today we have with us Cecelia Martinez, and she's a developer advocate for AppFlow at Ionic. Previous companies include Cypress and Replay. She's passionate about open source dev tools and building uh, inclusive developer communities. She likes to speak about web and mobile development, testing, and DevOps. She's a lead volunteer with Women Who Code, chapter head of Out in Tech Atlanta, a GitHub star alumni, and she has served on program committee for multiple tech conferences. Before transitioning into tech, Cecilia had her career in journalism and finance. She likes to use both sides of her brain to connect with people and solve problems. So, with this, off to you, Cecilia.
Awesome. Thank you so much, Anu, for that great introduction. Hi, everyone. I'm super excited to be here. I love Women Who Code. I've been involved with Women Who Code since 2019, and it's a great organization. So super excited to be here speaking today about customizing your continuous integration and continuous delivery, or what we call CI/CD, specifically for mobile applications. I'm a developer advocate for AppFlow. It's a mobile CI/CD platform built by Ionic. You may be familiar with Ionic. It is an open source SDK for building cross-platform apps using web technologies. Feel free to connect with me. I'm at Cecelia Creates on Twitter and GitHub. And you can also feel free to connect with me on LinkedIn if you have any questions or like to chat about anything related to web, mobile, or CI/CD. So the reason I'm here today talking to you is because mobile deployments are very complex. I come from a web development background. I've worked with multiple web frameworks like React, Angular, and even Vue. And when I got into mobile development, I was really taken aback by how complex it is to actually release your mobile applications to end users. And the thing is, coming from a web background and working with testing tools and CI/CD tools built for web, I realized that traditional CI/CD isn't designed for mobile and the complexities that come along with mobile deployments. So because of that, I'd like to spend today talking about what makes mobile deployments different across each stage of the software delivery lifecycle. I'm also going to talk about what specific considerations that you'll need in order to update or customize your CI/CD to start deploying mobile apps, as well as some implementation options that you have and some strategies that you can employ to start integrating automation for your mobile deployments. So let's talk about what makes mobile deployments different. And we'll start with testing. So when you think about web testing, typically you have maybe you think of like the testing pyramid or the testing trophy. What you are testing is a single version of your code base, a single version of your app. When you're testing for mobile devices, whether you're doing cross-platform development, and by cross-platform, what I'm referring to is using a tool like Ionic, Flutter, or React Native in order to build from a single code base, but deploy to multiple platforms like iOS and Android. So whether you're doing cross-platform or whether you're doing traditional native development, where you're building just for iOS using a tool like Swift, or just for Android using a tool like Java or Kotlin, you are going to have to deal with multiple different build types. What that means is you may have build types, at the testing level, at the production level, at the staging level, some for manual testers. You may even have different versions of your application that exist out there, and you need to take that into consideration and test those different types. You also have to think about device fragmentation. So your application is going to be running on an actual physical device, right? So you have like iPhones, you have Android devices, but it's not just those two. For each type, you have multiple different types of devices, what version of iOS that you're on, what type of Android device that you're on. And you have to test across all those different types of devices to ensure that your app will work no matter what device your user is using. You also have to think about test release channels. So when we think about web testing, we are in total control of how we run our testing. Typically, we will have a testing environment or a staging environment, or we may just have ephemeral environments that we spin up, and then whenever we have a pull request. For mobile app devices, both Google and Apple, their corresponding app stores, have test channels that you can use to deploy your applications to your manual testers, but you do have to keep those organized and coordinated. And then you also have to think about your test logs and feedback. If you have multiple different test channels and multiple different versions of your application out there, how are you going to aggregate all that feedback together in one place and make sure that you understand where there may be bugs in your application? Once your application is tested, another part of the software development lifecycle is actually building your app. So again, when we think about web, when we have a build, we're kind of like running maybe npm run build. And the only reason that we have to do that build process is because of modern web tooling. If we really wanted to, we could just write HTML, CSS, JavaScript, and then drop those in our static assets and just drop those files on a server, right? But we have a build step because of the bundling and minimization process by modern tools. When we think about building for mobile applications, we're actually creating a native binary, like an executable file that will run on a native device. So because of this, we actually have to go through that compilation process. This has specific infrastructure requirements, depending on if you're building for iOS or if you're building for Android. For iOS, you do have to have Mac infrastructure, so you need a Mac machine in order to build for iOS. You don't necessarily need a Mac machine to develop for iOS, but you do need it for the actual compilation process. Because you have multiple build types, you typically will also have to have multiple environments. So if you're building for both Android and for iOS, if you're doing cross-platform development, you need to have separate environments for those, as well as all of the build stacks and dependencies, any environment variables that you may need that are set up within that environment. And then the last thing, but probably one of the biggest obstacles I know that I have personally faced with mobile deployments is managing build signing credentials. We'll talk a little bit more about code signing, but code signing is what authenticates your application bundle, and it is required for deployment to both Google Play and also for iOS, for Apple App Store. And when you are building locally, typically you can use Xcode or Android Studio to generate that signed bundle. But when you're thinking about CI/CD, you do have to have those credentials installed in your environment where the build is taking place, which does complicate things. So once you do have your signed bundle, then you have to think about shipping. And again, shipping is going to be very different from web to mobile because of the app stores. We have total control over our own web deployments. I can push out whatever kind of app I want to my server. There's no approval process. There's no requirements that I have to fulfill. I can ship at any time and to my application for web. For mobile, you are, kind of beholden to these requirements and these processes developed by app stores. So in order to distribute to your users, you do have to go through the app stores. This has a pretty lengthy list of requirements, not only to make sure that your app is approved for listing, but then also the requirements associated with your listing in the App Store. These are going to be the things like your assets, your release notes, what version that you're on, making sure that you have the correct SDK versions. So you have essentially this kind of gatekeeper in terms of the app stores that you need to follow their processes and be really aware of what those processes are so you don't slow down your release velocity. And last but not least, this deployment stage that is different from between web and mobile is maintaining your application. So I add maintaining here, even though it's technically after the deploy process, because once you have a version of your app out there, you need to continue to support that version. When you release a web application and you release an update to that web app, everybody is on the same version of your web app, barring any, feature flags or maybe A/B testing. For the most part, everybody is going to be up to date on that latest version as soon as they hit your server in that browser. That is not the case for mobile applications. You may have seen on your own app, on your own iPhone or your own Android device, where you go to log in and it prompts you to upload a new version. Or you may have a really old version and everybody else has a newer version. They have, even like for iOS, for example, everyone had the newest emojis. I didn't have them yet, and it's because I hadn't updated my operating system. So I went and updated it because I wanted the newest emojis. But you can't really force a user in most cases, unless you use specifically force updates, to stay on the latest version of your app. So if you make any changes, you have to think about what versions of your app are out there and if they're being supported with that change. You also have to keep up with App Store requirements, maintain those build infrastructure and dependencies that I mentioned in the build stacks. And you have to think about the fact that because the App Store deployment process is complex, this also makes bug fixes and updates more difficult to deploy than it is for web. So overall, what this means is that it does require some cross-functional knowledge on your team. So you not only have to understand how to build mobile applications on your team, but a lot of times mobile developers are also going to be responsible, at least in some part, for the deployment and testing process as well. You may have a dedicated DevOps team, but they may not have mobile specific knowledge and need to lean on you for that. Or you may not have a dedicated DevOps team and need to figure out these kind of complexities. That's kind of different in the mobile world versus the web world. It also could mean that you have delayed releases if you don't have a consistent process set up in place, which is where automation can really come in handy. If you have to go through a manual process every single time that you go to update your application, that can result in delayed releases for your users, but then also in different developer experience and user experience across platforms. So say, for example, you have a more streamlined release process for Android than you do for iOS, or you run into hiccups with your iOS process. That could mean that even if you're developing cross-platform, even if you have one code base, the deployment process can actually result in you having delayed releases, and in meaning that your Android users may have the newest version, but your iOS users don't, all because of deployment and not because of that release process. So the sooner that you're able to start implementing automation into your mobile deployment process, the better, because as you can see, it's a complex process that requires multiple stages of testing. It requires App Store approval process. So the more that you can take away time from having to manually deploy, the better. So let's talk about how you can do that. Let's talk about how you can customize your CI/CD for mobile and the different things that you'll have to take into consideration. So the first thing is going to be your environment. You're going to need to have environment set up, whether that is a dedicated environment, but typically it's going to be something that's more ephemeral, like a runner procured on the Circle CI or GitHub. I use GitHub Actions for when I'm doing things manually, or I use a tool like AppFlow, which provisions my environments for me. But you are going to need Mac and Linux hardware if you're building for Android and iOS. And then you're also going to need to think about your build dependencies. Once you procure that hardware, what dependencies need to be installed in your environment? You can use container images to help keep track of those build stacks for you, or you can manually install them using install commands. And you'll also need to think about what environment variables need to be present at that build time. Now, when I talk about build stacks, this is kind of what I'm talking about. This is the build stack for AppFlow. So we have our own runners, and so we manage the build stacks for you for mobile builds. This is an example of our Mac runner and the Mac build stack. So we have versions of Cordova, Ionic, Node, Node.js, and NPM, Yarn. That is for us to be able to build cross-platform apps like Ionic apps, but also React Native apps. But then you'll also see we have a specific version of Mac OS. We have CocoaPods, we have Xcode. So we manage all these different build stacks, and then depending if you need a specific version of Xcode or a specific version of Mac OS to build your application, you can select the latest build stack, or you can select an older version. So if you're not using a tool to manage your build stack, you'll need to keep in mind what versions of each dependency that you need, typically using something like an image or a really, really specific build process or installation process as part of your pipeline. Then it comes the actual build step. So when you think about the build step, you need to know what build type that you're building for. And when I talk about build types for Android, there is debug and then release builds. Debug builds are kind of quick. They don't need to be fully configured. Those are for distributing to testers or internal stakeholders. Release builds are for when you're ready to actually, kind of do a more production build for the app stores. On the iOS side, you have simulator builds, which are only for running on simulators. You also have development builds. You have ad hoc builds. you have App Store builds, which is what you're going to be building when it's time to deploy, as well as enterprise builds if you're using Apple's enterprise services. You also will need to increment the version of your app during the build process. So it's important that you have a new version number for each build so that you can specifically tie a version back to a build log. Typically, you want to do this automatically. It is very cumbersome to try and manually update all of your build version numbers within your code base, especially if you're deploying cross-platform. So those typically will be a step in your CI/CD pipeline to increment this. And then I mentioned signing keys and certificates. You'll need to install those in the environment, a little bit more there. Then you'll have a build command that will go ahead and generate the signed bundle. And then you'll need a step that will essentially ensure that the build artifact of that generated signed bundle is then uploaded and made available to you outside of the environment. So I promised we'd talk about code signing, so let's go ahead and get into that now. As I mentioned before, code signing is about authenticating the security of your application. It kind of validates who was the person who generated the bundle. It validates that they're authorized to generate that bundle. And for iOS, it also validates, what types of devices the application can run on. But the purpose of doing this is when you generate a signed bundle, it validates that by the time it gets to the App Store, no malicious third party has altered that code in any way. So you created the bundle, you sign it off on it, and it stays signed and sealed all the way until it gets deployed to the users. So on the Android side, there are two signing credentials that you'll need to think about. One is called the upload key, and it's stored in the upload key store. This is what you use during build time. So the upload key is used to actually generate that signed bundle. The app signing key is used after you upload the bundle to the Google Play Store. So the app signing key is actually typically managed by Google, and that is used to sign your app right as they're deploying it to the App Store. So it's a little bit confusing because you use the upload key to generate a signed bundle, and then you use an app signing key after you've uploaded it. So that's why I wanted to clarify that. But upload key is what you're going to need to have installed in your CI/CD environment. App signing key, you don't need to worry about that right now. On the iOS side, you have also two credentials. You have a signing certificate and a provisioning profile. A signing certificate authenticates essentially the user or the person who is or the entity that is signing the bundle, whereas a provisioning profile validates what signing certificates can be used. It validates what devices the application can run on. And you have to have both of those installed at build time because both of those are used to generate the signed bundle. So an example of what it looks like in order to install these credentials within your environment. So this is actually an example from GitHub Actions on how you can install your Apple certificate and provisioning profile as part of your pipeline. The thing is, you kind of probably have experienced this before where you save secrets in your CI/CD environment. So, we can use that for your password. We can use that for the text-based credentials. But we have files that we have to deal with, so you can't just save a file as a secret. What you have to do is you actually have to encode that file as a base 64 and then decode it as part of the process in your CI/CD pipeline. So here we're declaring some environment variables. We're setting them based on these values that have been stored in our GitHub Actions secret. Then we're creating variables to store those files. We are essentially decoding them. And we have to ensure that they're in the correct path because, iOS for Xcode build, when you run that command, it's going to be looking in a certain location for those files to exist. So we not only have to grab them from our secrets and decode them, but we have to ensure that they're in the correct path that Xcode is going to expect when it goes to run that build. So as you can see, the process for installing signing certificates manually without any kind of tooling can be complex. And you do have to do this for each type of signing certificate and provisioning profile. So you can have a development or a distribution signing certificate, and then you can also have different mobile provisioning profiles for each different build type of your application. So keeping all of this straight can be complex, which is why we do recommend using a tool for shared credentials management for CI/CD. Okay, so once you have generated your assigned bundle, you did it, you figured out all the signed certificates, everything is great, you have that beautiful little signed package, it's time to actually deploy it up to the app stores. So it's not something where you just kind of take that bundle and it's immediately in the app store. You're going to need to go through a kind of a release process where you're going to go through multiple types of testing tracks before it's actually ready to promote to release. So you're going to need to think about, how you're going to connect to these app stores. There's various different types of tools to upload the binary. And you also need to think about how you're going to store those credentials in order to integrate with those binary upload tools. And also, what types and tracks that you're going to upload to. So Google Play and iOS both, let's say Android and iOS, I'll be more consistent there, both provide methods for you to test your application using kind of like official testing tracks. So on the Google Play side, they're called testing tracks. On the iOS side, you have a couple different options. But for Google Play, these are built right into the Google Play console. And you go through the process of starting with internal testing. So internal testing, it allows you to deploy your application, does not have to be fully configured yet, and you can deploy it to up to 100 testers. So this is good for your QA teams, internal stakeholders. You add them via email and you can deploy it. Once it's gone through internal testing, you can then promote it to alpha testing, or what's called the closed testing channel. This allows you to release it to a wider audience of testers. And then finally, you have beta testing. At this point, your app is actually in the App Store. So it's available to all users, but it'll be marked as beta, and it'll be, marked that it's still in that kind of testing phase. So you do typically will upload, and depending on your testing strategy, to one of these channels, and then promote that release through the channels as it goes through more testing, or send it back to fix any bugs, and then do a new version and go through the process again. On the iOS side, you have ad hoc releases. So ad hoc releases allow you to distribute up to 100 test devices per year. So it's device-based, not user-based. You do have to register the UUIDs of each of these devices. You can do that either in Apple Developer Program or by connecting the devices to Xcode and then syncing it to your Apple Developer Program. But if you need to distribute to a wider audience, they have the option of TestFlight. So TestFlight is a program available in App Store Connect. It allows you to distribute your app to testers via email address or a link. And essentially, they enroll in testing your app. They're able to download your app via TestFlight, and they can automatically get updated every time that a new version is available. Nice thing about TestFlight too is that it has built-in tools for getting feedback from your testers, like they can submit screenshots and bug reports and things like that. So that makes it handy for when you're kind of testing with a wider audience. So I did mention that, once you have deployed your application, it's gone through all the tests and it's been promoted to release, you have to think about the long-term support and updates of that version. So you may have a specific release cadence where it's, every 2 weeks, every Friday, maybe less than that. But typically you want to think about how often you are updating your app and how you want to handle any rollbacks or critical bug fixes. And all, kind of wrapped up all of this is that App Store approval process. App Store approval process is something that is always going to kind of be a roadblock to the update process. And one of the things that you can think about when updates, in particular, when it comes to cross-platform applications, is you have an option for what's called live or over-the-air deployments. So you can do this, I know you can with Ionic and Capacitor apps, you can do this with React Native apps, or you can also do this if you're using mobile micro front ends and you have embedded web content in your native application. So what live or over-the-air deployments are is that it allows you to update the web content within your application without going through the App Store approval process. So you can't do any native changes. So if you're making any changes to native functionality, you will need to go through a new release. And there's various tools available. Your app does have to be pre-configured for this. You have to kind of set it up in advance to be able to receive those live updates. But once you have done that, this can be a strategy for if you do need to make changes to your application that aren't related to the native functionality of your app. You don't want to rely on this entirely. You definitely will still need to go to release processes and new native versions of your app, especially if you want to keep the app stores happy. But this can also be something where if you have your app pre-configured and you have an eligible app type, that this can kind of help you send out updates to your users when you need to for critical fixes. And then finally, there's just a lot to maintain. You have to maintain all the dependencies for your dev stack. So if you're using a specific framework, making sure that you're using the correct versions of the SDK, any other build libraries that you're using. I mentioned those build stacks that need to be installed in your environment. Those need to be updated and maintained as well. Your certificates and credentials will expire over time. And so you want to ensure that those are being updated and that you have the most up-to-date ones in your environment. And then, all this boils down to your build environment. Are you going to use any type of images or configurations in order to store this information? Are you using YAML configuration files? All of this is something that you need to take into consideration as you integrate automation. So let's talk about some of the specific strategies for how you can implement all of those steps that I just talked about into your CI/CD pipeline. And when I say implementation strategies, I'm talking kind of more of a high-level, big picture approach to making these changes. So the first is that you can upgrade your traditional CI/CD. So if you have existing DevOps team or an existing, like somebody who handles the CI/CD at your organization, and you have existing tooling for web deployments, you may be able to leverage that tooling, but update it for mobile. This will require you to provision additional hardware and software, right? You do have to think about those build stacks. And you will have to also implement systems and processes to support mobile deployments across teams. So if you have a separate iOS and Android dev team, they're going to have different build stack requirements. They're going to have different processes. So both teams will need to coordinate with the DevOps team in order to make those that process smooth. And then you also may need to increase resources to speed up releases. Again, mobile builds are not the same as a web build. A mobile build requires more resources, so you may need to add more machines or take that build time into consideration now that you are automating your mobile releases. Another option is to let the mobile development teams manage. So this is typically what you see when you don't have a dedicated DevOps team, or the DevOps team or your build team or your infrastructure team does not have the mobile specific knowledge in order to make the updates. So with this strategy, the dev teams own their own mobile deployments. They will typically have to take their existing mobile knowledge of the manual process and then integrate automation into that and leverage CI/CD practices and tooling. So typically, so you'll have maybe like an iOS team that manages and provisions its own resources, an Android team that provisions and manages its own resources. Sometimes you can have a little bit of knowledge silo with this because each team is managing them independently. So you may have different tooling, different processes across those different teams. But typically there may be some higher level compliance, security, and vendor requirements that are needed at an organizational level. So it'll be the responsibility kind of your organization DevOps team to ensure that each individual mobile team is in compliance with those as they manage their own deployments. And then another option that you can use is you can also leverage a mobile CI/CD platform. There's a variety of options here. And so when I say mobile CI/CD platform, I'm talking about a platform specifically built for mobile deployments. So you have platforms that are, you have tools, I should say, that are platform specific. So that means just for iOS or just for Android. Example here would be Xcode Build. You have tools that are framework specific. So that is in reference to the framework that you use to actually build your application. So for example, there's EAS, which is for React Native applications. It's a mobile platform specifically built for React Native. And then you also have general mobile CI/CD platforms. This typically will support multiple different, both Android and iOS, as well as different frameworks that are used to develop applications. This can be helpful if you have concerns about wanting consistent tooling and processes across your different teams. And typically they are cloud-based tools. So your machines, your build stacks, and your credentials are managed in the cloud. They do have varying levels of customization and complexity. Some are more have more features that are more complex to manage. Some are YAML based, some are GUI based. But there's a lot of tools that are available out there. Some things to take into consideration is the DevOps expertise on your team. So do you have somebody who is willing and able, as they say on like airplane security, right? Somebody who's willing and able to manage those mobile deployment processes in an automated fashion. Is there any existing tooling or infrastructure that you can leverage? And then you'll also want to think about what platforms are supported by your organization and what frameworks are used to develop. So if you only have one team and you're just doing iOS, then yes, you may make more sense to use a platform-specific tool. If you have maybe your organization has 25 different apps across different platforms, and there maybe is 5 different teams who are using different frameworks, that if you want to have consistent tooling across all those teams, then you may want to go with something that supports multiple platforms. So I did want to share some examples. I'm going to exit out of my slides here. So the first thing I wanted to show you was an example in GitHub Actions of a workflow for an Android debug build. And I wanted to show you this because it kind of walks through the different steps that we talked about of the build process. So this is for an Android debug build. So this is probably like the simplest build you can get, right? You don't have to think about signing credentials. It's just going to be an APK file. But to run through the steps here, this is our workflow dispatch is going to be manual in this case. I don't have this one set up for automations, but it's going to be running on Ubuntu latest. So we have a Linux machine for Android build. We are checking out our code. And here in this section is where we get into that build stack requirements. So GitHub Actions runners do come pre-installed with actually quite a bit of dependencies. You can see the list of what comes installed on the machines, but there's quite a bit, including Android SDK is installed on there. However, you do need to specify which version that you want to use. So I'm using a GitHub action called setup Java, where I'm essentially specifying which Java version and distribution that I want to use for my build. And I'm also specifying that I want a cached Gradle, and that'll just make it faster going forward for future builds on my runners. Then I'm installing the dependencies for my application. So this is for a React Native app. And so I'm installing just using yarn install the dependencies that I need for that. The next step is I'm actually bundling my app. So by default, for React Native applications, you do have to bundle. So React Native is like a 2-step process. First, it bundles your app, which essentially is taking your React Native code and preparing it to be built for Android or for iOS, right? Because it's a cross-platform code base. Well, when you're creating a debug build in Android Studio, this happens automatically. But when you're running it in CI/CD, you do have to manually take care of this bundle step. So what we're doing is we're bundling the code, we're specifying the platform, and then we're also specifying the path where the output will be. So that's what this bundle output file is for. That's important for us to be able to use in the next step, which is going to be to take that bundle output and actually create our Android APK, our Android debug build. So we're running that command using Gradle, and we're running the assemble debug command. And then finally, I'm using the upload artifact action and to upload that build artifact that is available to me outside of my ephemeral environment. So again, this is kind of talks about the different steps that you need to think about in the build step process. I don't have any signing credentials in here. I showed that example for the iOS signing credentials earlier, but I wanted to walk through like kind of more of a full workflow. Another option that I mentioned is that you can use a mobile DevOps tool. So this is an example of a similar kind of automation in AppFlow. So AppFlow allows you to create automations using a graphical user interface. So here I have 2 automations from a React Native application. Whenever I push to my main branch, it will automatically create a release build for Android and then upload it to my Google Play internal testing track. It will also at the same time create an App Store build for iOS, and it will update it to test flight. And the way that this works is I've connected my signing certificates. So I've uploaded my credentials here for my development for iOS, as well as my Android and iOS credentials. So this includes, for example, let's not delete it, my signing certificate, my provisioning profile, and then my key store are all stored here in AppFlow. So whenever I create a build, it'll automatically apply those. I've also set up my destinations. So I have my Google Play internal, and I also have my test flight destinations. So those are already connected to my account. This allows me to create new automations. So I'm able to specify which Git branch that I want to trigger the automation. I can build for iOS. I can select my build stack here. So if I did need an older version of macOS, for example, I can choose my build type. It'll automatically pull in the correct signing certificate for that build type. Here's where I can add any type of environment variables or secret keys that I need to use, and I can save these as well. So I can manage those different types of environments that I may have. And then I can also automatically distribute to my App Store destination. And I can also trigger a webhook if I need to, if I want to notify like my team on Slack that a build has been completed. So those are some of the different ways, tools, examples that you can use. You can use kind of a more manual approach using something like GitHub Actions. There also is a great tool, I will say, called Fastlane. So Fastlane is a tool built by Google that allows you to essentially define what's called a fast file. It's kind of similar to YAML language, but build out certain steps for your mobile deployments. And it also has a tool called Fastlane Match, which allows for cloud credentials environment. So if you wanted to use something integrating with your own CI/CD, or you can use a more platform-based tool like an AppFlow or a Bitrise or something like that. All right, so to recap, we talked about what makes mobile different across each step of the deployment process. We also talked about how you can customize your existing CI/CD for mobile and what things you'll need to take into consideration, as well as implementation options. Before we hop onto questions, I just want to give a quick shout out. So Ionic is hosting our very first in-person conference this year in Austin, Texas, October 10th to 11th. We've actually had multiple online conferences before. I spoke at IonicCon 2020 before I even joined the team, but this is the first time that we're doing it in person. Would love to see some women who codes, people at the event. So the CFP is currently open. You can go ahead and feel free to submit to speak. Mobile and web topics are accepted. It is for, cross-platform mobile and web development topics. So I will also pop that link in the chat as well. But yeah, thank you so much. I guess we can take any questions if folks have them. And again, feel free to reach me at Cecelia Creates on Twitter or GitHub, or you can email us at appflow@ionic.io.
Thank you so much, Cecelia, for this amazing walkthrough for the CI/CD pipelines. So we do have a few questions. Maybe we'll go through a few of those to start with. It's with Melissa. She mentioned, she's asking, is there any way to add test nodes to test flight from the pipeline? It's annoying to try to remember which build has what changes.
Yes. So there is. You essentially would want to integrate with the developer API in order to do that. So I actually saw a talk recently. If you give me a second, I actually might be able to find the link here. But there was a talk recently at Deep Dish Swift, which is an iOS conference, about kind of CI/CD. And one of the examples was updating the release notes as part of the test pipeline. And so that is something essentially that you can do by integrating with the API in order to update that. So I think I have the link to the slide. So I'll find those and I can pop those in the chat as well. But it is something that you're able to accomplish, which can be really helpful. Oh yeah, here it is. So I think that this was referring to a different release notes, but I think you could also use the test notes as well. So that is a link. I just popped it in the chat to the slides. It was a talk by Rundrak Riam at Deep Dish Swift, and it had some specific examples for integrating with the API from the pipeline.
Right, perfect. So another question by Melissa herself was, would you recommend having a dedicated DevOps for mobile, or would mobile devs have assigned time to manage this?
So of course the answer is going to be, it depends, right? But I will say I have been very surprised the more and more I talk to mobile developers at how little dedicated DevOps support they get as compared to web. So in the web world, everything is automated. We expect that really great developer experience. We expect those dedicated DevOps resources. And I don't see that as often in the mobile world, which is interesting. I do know that it can be very complex to manage different platform complexities. I would say maybe what I would recommend is if you do have separate teams, if you have an iOS team and you have an Android team, that it may make more sense for each team to own their own deployment process, because they're going to be very different. It's going to be more specific to their platform, versus if you have a cross-platform app where the development process is going to be the same, the releases are going to be the same, then you may want to lean more on dedicated DevOps, because it should be a very similar process, but just with those different configuration details. So that may be something to consider in making that decision, is if you're developing cross-platform or if you have dedicated teams for each platform.
All right. Thank you so much for that answer, and Melissa for those questions. Next question is by Kendra. She want to know what kind of files are the key stored in? Is it .env?
It's a great question. Yeah, so you actually have a .keystore or a .jks file. So that is generated. You can either generate it in Android Studio, which is what I would recommend. I think it's easier. Or you can use a tool called KeyTool, which is a command line interface tool to generate that file. But it's actually its own file type. So it's .keystore or it's .jks. Now, if you're only ever building locally, typically what you would do is maybe keep that file in your directory, but then add it to your Git ignore so you don't check it into source control. Otherwise, you're going to need to ensure that that file itself is encoded and then decoded in your environment.
All right, perfect. Thanks again. So another question is from Jess. Question is, I find that I'm waiting quite long for my build to process in App Store Connect, and I'm basically refreshing the web page until the build is available. Do you know if there is any API call or trigger you can use to notify when the processing is finished?
Oh, that's a good question. I know that it's possible. Well, there's 3 different stages of uploading to App Store Connect. So, for example, like our AppFlow deployments, because we deploy to App Store, they can kind of fail at 3 different stages. The first is we'll get an initial immediate response if something is wrong. Like, for example, if you try to upload with the same version number, that will get like a quick response. If the credentials doesn't match up or something like that. So there's like an immediate response that you get if something fails. Then there is kind of something that comes along later where after it's been uploaded, and the upload process is successful, then there's a second phase where it could be there could be an error or an issue that takes place. And then finally, of course, if it's been promoted for release, you may get an email later on saying that something is like wrong with the release, right? But so I'm thinking if there is something in that initial step, then like I know that we're interacting with App Store Connect on our tooling, then that could probably be hooked into in some way. But I don't know about when it's actually ready for release. So if you can enable automatic updates for test flight so that you'll get every new version is automatically available to your test flight testers. And I know that you do get an email when that is ready. But I'm not sure of a specific API endpoint for when the build itself is ready in App Store Connect. So yeah, I'm not sure, but that would be really helpful. But maybe that very first like failure could be at least indicative that there's a problem.
Yep, for sure. So very interesting question, Jess. Thank you so much for asking, and Cecilia for the answer. So I think we have just one last time for just one last question. So would the CI/CD pipeline change if we are trying to develop a cross-platform application?
Yes. Well, yes, I think so. And I think the biggest part of that is going to come in when it comes to testing. So you can test at multiple different levels of your application, right? So you can do unit tests, but if you're developing cross-platform, typically you're using some like if it's Flutter or React Native or Capacitor, you may want to test at the level before you get to the actual bundle process, right? So you may want to like run your tests early, because testing on the actual devices or virtual or real devices after you compile the binary becomes more complex, more flaky, like more expensive. So the testing may be different because you may want to just try and run your tests earlier in the process before you get to the platform specifics that you need to test on an end-to-end fashion. And then also if you're developing cross-platform, like you may want to run through like a test process and then like move forward with the build steps before you provision your Mac hardware, before you get into all that complexity. But otherwise, as you saw, like I have like a specific a trigger that will build both iOS and Android and deploy to the testing. That's like a very simple CI/CD pipeline, obviously, but yeah, I would say you may want to have a different testing strategy to leverage some of those benefits across platform.
Perfect. Thank you so much, Cecilia, for sharing such an insightful topic, CI/CD pipeline, and everything, and all the audience for interesting questions and giving us time today and joining us for this talk. Looking forward to seeing you all in the other sessions as well. And once again, just to conclude, thanks a lot, Cecilia.
Yeah, it was great. Thank you so much for having me and the great questions.
All right. Thank you. Bye, everyone.
Bye, everyone. Cheers.